Bad day for me. Today, this American Standard GPH hydronic gas heater pretty much looks like it was installed in 1971. I've gone on various YouTube videos and noticed that these models were pretty much from probably the late 60s, early 70s. Okay. There is, of course, a gauge for your pressure and a great gauge for your temperature. There is not a device to check the water. This device here is called the aquastat. It is similar to the original that was here by the manufacturer Honeywell, where you're able to connect the thermostat, and then you have a relay that should engage to tell the burner to turn on. The wiring diagram is pretty straightforward. There is a circulator connector and there is a burner connector. There was a problem where there was no furnace operation. An electrician came in, identified that the pump, which was a Bell Gossett 100, similar to this large unit here, failed. So that would not circulate the water within the piping system. He also identified that the aquastat, somehow the relay, would not stay on to do a heat call to make the burner turn on. So what we have something very similar to the new model that was purchased. It has more connections here for thermostat. It's a newer design. It also has, of course, the knob to do your high setting and low setting, which the original had, and the new one has. Why am I showing you this? Because it pretty much looks the same. This type of board here, not this box here, okay, the transformer on both. Now, the local hardware stores charge you what they have in supply. I could not get a Bell Gossett 100 because one place was charging $559, and the original Honeywell aquastat was $378.95. That was one location. At another location, the same Honeywell type device was actually made by Resideo, and it cost $357.19. It was model number L8148J1009, and it works with the millivolt system, 24 millivolt system. The gentleman said it was plug and play. Pretty much you take the old wiring for where will be the burner as the pump and the thermostat, and pretty much that's what he was talking about, plug and play. Now, on a millivolt system, it would have this type of igniter with a positive and a negative. This one, of course, was probably here for more than 20, 30 years. It looks damaged. This is the igniter. This is the item that ignites the gas when you receive the voltage in the millivolt system. Of course, this wire comes from the aquastat. It must send the signal to tell it, hey, I'm ready to open more gas so that the burner can light up. The pilot is on. You can hear it. Okay, one of the things, if the millivolt system was damaged, you would have no pilot, someone had said. One of the simplest techniques is to put a voltmeter to prove also that you might have, 500 milliamps, 600 milliamps, 700 milliamps to start this. 670 milliamps, volt DC. Here you have presumably there should be something there coming back to jump, but this was set up different. Now these two new parts, the new shorter pump by Bell & Gossett And the new aquastat by Resideo cost, as you can see, there's the model number, the same model number for the aquastat from another supplier. This one, unfortunately, was $378.95, and the pump was $285.89. So here's an expenditure for the building of $708.89 with New Jersey sales tax. So what we're going to do here is I turned off the breaker temporarily. When you have a call for heat, your furnace and circulating pump will work. But what happened is, I believe, on this furnace, the relay became damaged less than a day's time. There is, the furnace just ignited after getting a call for heat. A thermostat was set up just so that I can run the unit temporarily. Right now we have a call for heat. It says heat is on, call for heat. If there is no call for heat, then the furnace is supposed to turn off. Call for heat, the furnace will turn on. You've heard the noise. Now, originally, during some troubleshooting, this is the new Bell Gossett circulating pump, NRF-33. Okay, a small unit. This is a first floor and second floor zone to gas cast iron radiators, and there is the original Bell Gossett 100 for a baseboard system. So what happened here is the automatic switch and the manual switch, somehow this does not work as intended. If you put it into automatic, it should automatically shut off. I believe when millivolts can run the furnace without electricity. One of that technique. If you don't have electricity, the millivolt system is supposed to work. Now, when we did the testing, we were told that the transformer is supposed to send 24 volts for the T. But every time we tested for T at 24 volts, it was nothing. We also tested TV, which is part of the thermostat. That was nothing. Now, presumably, this unit is supposed to bring 24 volts between the W and the Z on that jumper. So on videos, they indicate that you should have 24 volts on Z. If you don't have the jumper, you're not going to get 24 volts on W. So if you put the jumper, you should get there. But somehow I don't get 24 volts. The electrician took a look at that. He couldn't figure that out. And he was able to know in this area that there is, of course, 120 in circulating pump area and 120 for the, oh goodness, I can't remember, the burner and the circulating pump. Okay, this is your relay. I'm not touching that. So what he did was, he has the thermostat, red wire, going correctly to TV. He has the thermostat going over to T. That is one thermostat. Then he has another thermostat, which somehow he set up a little bit different. This thermostat, he seems to have a black wire that's going to something coming from the inside of the furnace. There's the wire coming from the furnace. He's got a wing nut, and he's getting part of the thermostat, maybe to turn the furnace on. Then he has another wire, the other part of the thermostat, that he connected to the relay. So either the relay itself is damaged, or he connected this initially wrong, because I've never seen the thermostat, as you could see right here, going inside, and the thermostat going to the relay. So he told me, since this is 2 zones, the original Honeywell, this is the second zone, which goes to the basement. He indicated to me, keep that thermostat, let's say at 60 or 65 in the basement. So that is some kind of shorting out or reaching the lower limit that the furnace will turn on. So this kind of setup is odd, but it actually is giving heat to the moment, because I suspect that something happened to the relay, or there's some kind of other part that has damaged. But as you can see, this wire is going to a makeshift thermostat. We keep the thermostat here. It's set to turn on the heat. And you can see that it's supposed to go to TV and T, just like the other thermostat. This red wire is for the basement zone, and this white wire is for the basement zone. So that is the other thermostat. If I go and turn this thermostat off, which is a mercury-based thermostat, the furnace will turn off. So this is what he set up. He set up where the second zone basement thermostat will actually be set at 65, 60. He made that choice. And if it hits that setting, it's supposed to turn the furnace. Or if not, the furnace will continue on. So you can see that this thermostat is actually giving some kind of power to inside the well to ignite the furnace or bring the power to the millivolt. And then the other wire that he has here, he has taped up. He has taped up either A, he's taped up where, yeah, he has it taped up. Where's it going? I can't really see. It's very tough here. But he has one wire coming in here with some tape he put, and another. So he did some invention here to get this to work. So I'm just telling you this, that maybe this aquastat, which is supposed to be the manual and automatic mode, doesn't work. And he was able to modify this. I am not an electrician. I am not an HVAC tech, and I am not a plumber. So I am giving you this information of what I observed and how it's currently set up. So if I turn the emergency breaker off, circulating pump will go off, furnace will not turn on. So previously when we did this, I could never get the millivolt system to ignite the furnace. So this is what it is on this type of American Standard gas boiler. And it was built in 1969 probably, or 1970. It was installed here in 1971, if that label. It is series 4BNSEJ2. And it's a GPH 135 rating. And presumably is, of course, natural gas. So it is working. It's one that has been identified on a couple of YouTube videos, but there are different reasons they were showing that. They were showing tune-up. As you can hear, the gas has been ignited. And at this moment, the pressure is 20. It's at 150. When the initial problems were occurring, It was at 230, and it was fluctuating the pressure. That was on the day that he installed it. And the pressure relief valve was, of course, bringing out steam. And that is one of the reasons that it looked very dangerous, and believe that was related to not bleeding the radiators. Since he put a new pump, water had escaped, and then we filled up the water, but he was running out of time. It was a Saturday, pretty much at 7 p.m., and he was tired. The electrician, the next day, he came and looked at it after he told me to disconnect the breaker so that it would not work. And when I disconnected the breaker, it was really erratic because the furnace would turn on. Steam would come out of the pressure relief valve. So either something tripped, something reversed, something shorted in the aquastat. You have a good day, and maybe this can help somebody out.